Okay. Alright, so let's look at another example. Okay, example 5.6. Okay, solve the PDE below using the separation of variables method. So we have this kind of PDE. Okay, 4 del squared u del x squared equal to del u del y. So this one you can write as 4uxx equal to uy. Okay, 4uxx equal to uy. Okay, so in order to solve this, you need to consider two steps, where the first step is separating the variables and second step is to solve the separated equation. Okay, and to solve the separated equation, you need to consider all the three cases. Okay, case 1, case 2 and case 3. Okay, so okay, to begin, for solving the PDE, so we assume that the solution will be in the form of x times y. Okay, and therefore, okay, this is from the question. So as what I did just now, so you can write as 4x double prime y equal to xy prime. And the first step is to separate the equation. Okay, so how to separate? So you need to divide both sides with xy. And if you divide by xy, so you will have x double prime over x equal to y prime over y. Okay, this one, actually this 4 you can bring as a coefficient for x double prime. But maybe it's easy for us to put this 4, okay, for the y equation. Okay, so it will become 1 over 4. Okay, right. So this one is actually you just divide both by xy. So that is why you will get x double prime over x, and this one you will get y prime over y. Okay, and we put it equal to k as a constant. And we do not know what is k. It can be positive, it can be 0, it can be negative. So that is why you need to solve all the three cases. Okay, so before we solve the three cases, we need to construct the ODE, ordinary differential equation. So we have from x double prime over x equal to k, so we can write as x double prime minus kx equal to 0. Okay, and for the y, we can rearrange and it becomes y prime minus 4ky equal to 0. So now you have two equations where these two equations is separable, and you need to solve the separated equation by considering all the three cases. Okay, all right, let's start with case 1. Okay, k positive, so we set k equal to lambda squared. Okay, so this is the equation is x double prime minus kx equal to 0, and also you have y prime minus 4ky equal to 0. Okay, you have two equations. So we solve for x first. Okay, when you want to solve for x, so we have x double prime minus lambda squared x equal to 0. So this one you can use the same as in chapter 2, where you write in terms of m. So you can have m square minus lambda square equal to 0, and therefore you will get m square equal to lambda square. So this m square equal to lambda square, since you want to find the roots, right? So m is equal to plus minus lambda. Okay, so it can be one is positive lambda, one is negative lambda. So it is real and distinct. Okay, because one is positive lambda, another one is negative lambda. It's real number but different. Okay, and when you apply the real and distinct solution, So we can have the general solution for x is C1 exponent lambda x plus C2 exponent negative lambda x. So it's just the same as this one. A exponent m1x plus b exponent m2x. Okay, because we have two roots. One is positive lambda, one is negative lambda. So you get this as the solution for x. Okay, so we have done for x. Next is for y. Okay, y, we have y prime equal to 4 lambda squared y. So it comes from y prime minus 4ky equal to 0. When you have k equal to lambda square, so you'll have y prime minus 4 lambda square y equal to 0. Okay, and since if you substitute or if you write in terms of characteristic equation, so you have m minus 4 lambda square equal to 0. So m equal to 4 lambda square. So you only have one root because this is linear, okay? M minus 4 lambda square. Okay, so one root which is 4 lambda square. So if you use the same method or procedure in the previous example, so you can have the y is equal to C3 exponent 4 lambda square y. Okay, alright, so we only have one term. You don't need to put C4 exponent because we only have one root. Okay, for x we have two roots, so that is why you have a exponent m1x plus b exponent m2x. But since we have only one root, so we don't consider the second part. Okay, alright. So this is our y, and since we have already obtained the solution for x and y, so you can combine to get the final solution for PDE by implementing the case 2, which is k equal to lambda squared, k positive. Okay, so you will get this as your answer. Okay, this is from x and this is from y. Okay, alright. So next we will proceed. Okay, we will proceed with case 2, which is case k equal to 0. Okay, I will write again the equation. The equation is x double prime minus kx equal to 0, and also y prime minus 4ky equal to 0. So when k equal to 0, so you will have m square equal to 0. So m square equal to 0 means that you will have m equal to 0 and 0. So you will have real but repeated, the same roots. Okay, so because you have two roots, because it comes from m square. So two roots which are real but repeated later. Okay, the same roots. So if you implement the formula or the general solution, y equal to a exponent mx plus bx exponent mx. Since we have m equal to 0, so a exponent 0 plus bx exponent 0, so you get a plus bx. Or you can write as this form. So it becomes c for x plus c5. It's just the same. Okay, so this is the solution for x. Okay, meanwhile for y, okay, since you have k also equal to 0, so your solution is or your characteristic equation is m equal to 0, so you only have a constant c6, and therefore you will get uxy equal to x times y. So this is x in terms of x, this is y. Okay, where our y is just a constant. So multiply, you can have okay, the answer like this. Okay, and actually A2 is equal to C4 times C6 and B2 is equal to C5 times C6. Okay, so let's move to the last case, which is case 3, k negative. Okay, how to write the k negative? So we just put k equal to negative lambda square. Okay, so we will have the equation. Okay, the original equation is x double prime minus kx equal to 0. This is equation 1. And for equation 2 is y prime minus 4ky equal to 0. So when you substitute k equal to lambda square, negative lambda square, so first equation will becomes like this. X double prime plus lambda squared x equal to 0. Okay, using the same process. So you write in terms of characteristic equation, and we will get m square equal to negative lambda squared, and therefore you will get m is equal to plus minus lambda I. Okay, because you have square root of negative, right? So it will give complex numbers, okay, which is plus minus lambda I. So for complex conjugate, we have the general solution, which is okay, C7 cos lambda x plus C8 sin lambda x. We just use the formula, the general formula, which is exponent alpha x and then multiply with a cos bx plus b sin bx. Okay, where so we have the root as a plus minus bi. Okay, since our m is equal to plus minus lambda I, so our a is 0 and our b is lambda. So that is why you get this as the general solution. Okay, so this is x. Okay. Okay, last is to find the y. Okay, y comes from y prime minus 4ky equal to 0. So when you substitute k with negative lambda squared, so you will get y prime plus 4 lambda square y equal to 0. Or you can write as y prime equal to negative 4 lambda squared y. And this one, if you write the m plus 4 lambda squared equal to 0, so your m is equal to negative 4 lambda square. And since we have only one root, so the general solution is equal to C9. Okay, we just continue from the previous C. So C9 exponent negative 4 lambda squared y, because this involves the y as the variable. Okay, so this is seen as y. Okay, so we can combine, okay, the general solution to find the general solution in case 3. So we can multiply the x equation with y equation. Okay, and simplify, so you get this. Okay, so now for this equation, for the previous examples, so for the previous example, you will get 3 general solution, okay, from 3 cases. So case 1, you'll get 1 solution, case 2, another solution, and case 3, you'll get another solution. So you have altogether is 3 general solution for the PDE. Okay, so you can try this exercise. I will give this the answer later. Okay, so that's all for this week. Thank you for listening, and I hope if you have any problems, so you can text me or you can ask me during the next class. Okay, so thank you.